lesson 9.4, we're going to be talking about annuities. And in annuities, it's different than what we were doing in the last lesson. In the last lesson, we were taking an amount of money and putting it in an account and leaving it there and letting interest accrue. In annuities, it's like your retirement plan. You're going to be taking the same amount of money and depositing it every month into an account. So the formula that we're going to use to get the amount of money that you will have in the account, S is the amount at any particular time. And we're going to, instead of using P for a principal, because principal we put it in and we leave it, we're making a payment every month. Then we're going to use 1 plus R over N. See, that's the periodic interest rate. So it's the rate divided by the number of times it's compounded, raised to the NT power. The number of times it's compounded times the number of years, minus 1. And then all of that's going to be divided by the periodic interest rate, which is R over N. The rate divided by the number of times that it's compounded. So now let's go back to the problem that we had in 9.1 where we're going on vacation or we're saving toward a retirement or whatever. And the amount of money that we are going to put into this investment every month is, let's say, $200 is what we feel like we can budget to go into this account. And this is a long-term account, so we want to leave this in until we're ready to retire. So let's say we decide that we want to leave it in for 30 years. So that's our time, 30 years. We are going to receive a 5% interest rate since we've decided that we will leave it in for that period of time. And that's going to be compounded monthly. So after 30 years, how much money are you going to have to retire on? Or how much money after 30 years are you going to have to go on vacation or whatever you're planning to save for that long period of time for? So the amount of money that you would have in your annuity if you had $200 earning 5% interest rate, compounded monthly, raised to the 12 times 30 power, minus 1, divided by 0.05 over 12. Now we have to be careful how we type this in the calculator. We have to remember our order of operations. Order of operations says to work within the brackets, doing the grouping symbols first. So first I will divide 5 hundredths by 12 and then add that to 1. Then I will raise it to the power. Subtract 1 and get an answer for the numerator. Then I'll do the division on the denominator, and then I will divide the two together and multiply by 200. Multiplying by 200 will be the last thing that I do. So I'll take 0.05 divided by 12. Now I can put that on the denominator. And I can also add that to 1. So that gives me this sum. Then I'm going to raise that to the 12 times 30 power. Well, 12 times 30 is 360. So I'm going to take 1.004167 raised to the 360 power minus 1. So when I take this raised to 360 power minus 1, I get 3.4678. And I'm going to divide that by 0.004167. I'm going to multiply that by 200. And the amount I would have is $166,452.96. So that would be the amount of money that I would have in my account after 30 years. Now, the problems where it becomes a little bit more complicated is if you're looking for the amount of time that you would have to keep the money in an account in order to have a certain amount of money. So if I know how much money I want, I know what my payment's going to be, and how long is that going to have to be in there in order to get that amount. And to solve for that, that's where you'll have to use the natural log. So anytime you're looking for time, you'll have to use the natural log to get that exponent down out of down into the problem so that you can solve for the variable. So let's look at an example like that. Let's say that I think that I could retire on $200,000. So that's going to be the amount of money that I want to end up with. I feel like I can put in $300 a month out of my paycheck if they will give me 5% interest compounded monthly. But how long will that have to be done in order for me to have the amount of money that I will need to retire. So how many years am I going to have to work in order to make this happen? So I start out with my formula, which is S is the payment, 1 plus R over N raised to the NT power minus 1 over R over N. So I want $200,000, and I can put $300 in monthly if they will give me a 5% interest rate compounded monthly So it's compounded monthly for some amount of time. Alright, so I'm going to change my payment to be $400 a month. So now I can divide both sides by 400, and that gets rid of this part of the problem. So I can mark off, and 4 into 20 is 5 with 2 zeros. So that's going to give me 500. Now I'll go to work on solving this problem. We know that 1 plus 500 divided by 12 is 1.00416667. That's raised to the 12t power minus 1 over 0.00416667. Now, to solve this, remember the goal is to get t out of the power, get the variable out of the power. So I get rid of this denominator by multiplying both sides of the equation by the denominator. So I'm going to multiply 500 times 0.00416667, and that gives me 2.08335, and that gets rid of that denominator, and I now have that equal to 1.00416667 raised to the 12t power minus 1. Now I can add 1 on both sides of the equation. That gets rid of that. So I have 3.08335 is equal to 1.00416667 raised to the 12t power. So I finally isolated the variable term. So everything is away from the variable term, and that's when you can take the natural log. So I'll take the ln of 3.08335 is equal to the ln of 1.00416667 raised to the 12t power. The 12t comes out in front of the log, and I'll divide both sides by 12 ln of 1.004167, and that will make T by itself. That's going to give us the amount of time it's going to take for me to have $200,000 if I put $400 a month into the account. Now remember, I cautioned you before, the 12 goes out, the LN goes out, and we're left with T. But I cautioned you before about how you type this in your calculator. The numerator needs to be enclosed in parentheses. So I have parentheses, the LN, and then it puts a parenthesis, 3.08335, close. That closes the LN number, and that closes the numerator. So I have the numerator closed in parentheses. I'm going to divide that by, and I have to enclose the denominator in parentheses. So I have a parenthesis 12 times the ln of 1.0041667, close the parenthesis on the ln, and close the parenthesis on the denominator. And I get 22 rounded to the nearest tenth would be 6/10. So I would need to work 22 6/10 years, putting $400 a month into an account, getting 5% compounded monthly, and I would have $200,000.